we're going to do this one unit and then we're going to do unit 2, which is over something else. It just doesn't satisfy the way that this class works, because everything in this class is cumulative by nature and everything is interconnected. So there's no opportunity to be like, we're going to learn about this topic and then we're going to move on to the next topic, because that topic will use it. It's sort of like math in that way, and the scope of what we're talking about gets larger over time. So this is the narrative. Everything on Earth is highly interconnected with numerous natural systems that vary over space and time. Living organisms require both energy and resources, and therefore conversions in energy and matter underlie all ecological processes. Organisms can respond to changes in the environment, but survivability is dictated by biology and frequency and severity of disruption. These first 3 statements of the narrative is really going to be the scope of our work, save today, for up to December. I want to understand as expect it to be, as a system that 4.5 billion years has been churning a number of things that are predictable and manageable and understandable inside of that. And so we really want to understand Earth as we expect, and then we want to see all the ways that human impact, which has been extremely severe, has changed Earth over time, which will be 4 and 5. And then we're always technology-minded in this class. We're always optimists in this class. So we do spend a lot of time on the sustainable development kind of side of things, which will be the end. We are going to talk a little bit about human alterations. Oh, it's locked. I'm who locks the door if you're late to class. That's not me, but that's just how it happened today. But we are going to talk about human systems a little bit today, because we need a little bit of a foundation in a couple things before we explore other stuff deeply. You don't have to write anything down about this. It's on the syllabus, but this is the design of the class, okay? Here's what we're going to accomplish today during our lecture. It's a couple things. We're going to define the field of environmental science. It's a very important topic. We're going to talk about all the ways that humans impact. And this is some scientists who study this, they dedicate their lifetime to the second bullet point. We're going to look at it from about 10,000 foot view, a very high level overview of some key things to understand and some characterizations. And by that, we'll be looking at these indicators and how things are changing over time. And then we'll give a quick definition for sustainability and explain how it can be measured. Measurement in science is a really important thing to do. And so we'll get to that a little bit as well. All right. This was from yesterday in the news, the Amazon rainforest. It's one of the biggest global news stories happening right now. This is a common thing. So when I say, here's an example of something I would give you on an assessment, don't be surprised when there's something on your test that was in the news yesterday. That's a common thing for me to do. So this is something, we know a lot about the Amazon rainforest because we've been looking at it for a couple days now. But yesterday on the news, in interviewing one of these scientists, we're going to listen to this news clip, which is about 5 minutes in its entirety. The news audio kind of thing is one of the hardest sources of literacy for students to engage with. And so I felt like it would be a good opportunity to get into that early, because a lot of good information can come from these radio news sources. So while you're listening, these are the 4 questions that I'd want you to try to address from the interview that's taking place. So take this opportunity to practice a little formative assessment. Here we go.
Fires continue to rage in the Amazon today, covering more than half of Brazil in thick smoke. Fires in Brazil are up 84% from this time last year, according to new data from the National Institute for Space and Research, also known as INPE. For more on this, let's bring in Carlos Nobre. He is a climate scientist in Brazil. He's on Skype near Sao Paulo. And Carlos, we've seen those astonishing images where you are. It's dark, there are heavy plumes of black smoke, and that's nearly 1,700 miles away from the Amazon.
Yeah, that's true. That's 1,700 miles away. And there was a very uncommon phenomenon, which was this plume flowing south from the Amazon due to these very high rates of biomass burning fires, reaching many parts of South America, subtropical South America, and then this plume of smoke meeting this cooler air coming from the ocean produced some clouds, stratus clouds, and so that those clouds captured this particulate, this black carbon. So that's why at 3 p.m. it looked like it was already dark.
We want to get an understanding of what appears to be devastating fires. We've been hearing about President Jair Bolsonaro's encouragement of industry on that land. And scientists and conservationists are saying that he's to blame for these fires. What do we know so far on what's causing these fires, and if it's linked at all to Bolsonaro's policies?
Well, certainly these policies, federal government policies, have to be blamed by the tremendous increase in the number of fires and also the high rates of deforestation. Unfortunately, deforestation rates, cutting down large tracts of Amazon forest, has been going on for a long time, particularly since 2015. Deforestation in the Amazon has increased. But however, in the last several months, there is a peak, there is a surge of deforestation, a surge of fires. And this has to do with his political speech, which is to encourage all these people to expand the agricultural frontier, mostly grazing land for cattle, but also for grains, into the forest. And basically the message is, economic activity is cattle ranches, croplands, and the forest has no value, so move on, go and deforest. And of course, the people down there doing this illegal deforestation, most of the deforestation is completely illegal, most of the fires are illegal. They were certainly voters of this president, but they felt very encouraged that almost like no need to abide by the law, is a wild west, and do whatever we want. We are not going to be punished.
Yes, you mentioned since 2015 there's been massive deforestation efforts. We spoke with one scientist from INPE, the satellite agency, which released this data this week, that says while 85% sounds like a big spike, they've seen much worse in the past. He took us back to the 80s where he said this is about average. What are your thoughts on that?
Of course, deforestation rates have been very high in the Amazon in the last 30 years. In fact, the peak deforestation rates happened in 2004. So what is very sad is that after the success of reducing 75% deforestation rates and still, producing agricultural products, we reverted that trend, and deforestation rates are increasing. But very worrying is that this year there is a surge of deforestation and fires. It seems that the people there are moving onto the forest very aggressive.
Mm-hmm. You're scientists on the front lines of this climate crisis there. I can imagine this has an emotional toll on you. Do you have hope that we can stop this in time?
We have to stop that in time, and there is a global concern. A recent opinion poll released this morning here in Brazil showed that the vast majority, 90% of Brazilians, are against deforestation and fire, including the majority of President Bolsonaro's supporters. His voters are against deforestation. So we have to change that, because nobody wants that mode of development. And I hope, keeping international pressure, do not buy products coming from deforested areas. So if we succeed in that, in those campaigns, I'm sure we will have all Amazonian countries, but particularly Brazil, under this government, will have to change its policy towards the Amazon.
Carlos Nobre, he is a climate scientist in Sao Paulo. Thank you so much, Carlos, for taking the time to talk with us about this.
Thank you very much for the opportunity.
All right, let's get into it. Let's think about a couple key stakeholders here, and I really want to get to questions number 2 and 3. Those are really important. So what would be some of the stakeholder groups that we can identify? Yeah.
The president and his cabinet.
So the president and his cabinet, a government, and in terms of our stakeholder definition, we're talking about what? What do we think about for our working definition for stakeholder groups?
Stand to lose or gain.
Stand to lose or gain in a group, and it could be an individual as well. So in this case, the president could be one. His cabinet and his administration could be considered a broader one. What do they stand to lose or gain in this case?
They can gain money from the lumber that's being cut down, and also if farmland increases on the part that's cut down, they could profit from that.
So we've got some, those could be under an economic development kind of standpoint, Joe?
Also re-election because he promised for deforestation, and that's where he's getting a lot of support.
Which is a really interesting thing. Great.
It was mainly what Joe said, but it's like it can help his political career in the long run by following through on what he said, where if he just changes it, then people aren't happy with him.
So there's some political calculus that's involved in this, absolutely. When you say the economic development from timber, nuts, rubber, whatever is being used in the space, cattle, which was a big one that we've talked about, that's one. Those farmers and those political entities are one stakeholder group. For the rest, because there was somebody else that was mentioned. Who else has something at stake? If they're making all the goods, what happens with the goods?
I guess the consumers.
Which is all over the world. It's a global economy. So we are stakeholders as well. We have something to gain or lose by this. Cheap costs of goods and etc. What's amazing about this, so the Brazilian policies, a lot of what comes out is he's saying most of the deforestation is illegal. So they're not policies. A lot of it is just he set the tone through rhetoric, but there were some specific policies. Did anybody happen to catch what it was?
One of them encouraged producers to head further into the forest because the forest inherently has no visible value.
Okay.
The production does.
So there's this $8 million per day per hectare square of the Amazon. That's the valuation from this scientific article that we found. But nobody can realize that. Nobody's writing an $8 million check. It's just because of the ecosystem services, right? So that's more on the rhetoric side. Did anybody catch a specific policy change? I know it's a little bit nuanced if you're not a political person, the difference. I'll give it to you. It's the deregulatory action. So they used to be illegal for certain activities, and some of those activities are no longer regulated or controlled. They're illegal. So that's a major change. That's a major change, and the president brought that on. I want to just kind of shelf number 4 a little bit. I'm going to let that exist because we'll kind of come back to that at a future date. But number 3, how is this rate compared to history? Yeah.
I know in the beginning it specifically said that fires alone are up 84% from last year.
84%. So if we're looking at a history when the scope is a couple calendar years, massive increase.
But then from before those couple calendar years, it was at kind of an all-time low, and then the highest was back in like the 80s.
Super high in the 80s, a peak at 2004, and then some suppression, and then back up. So this is a good exercise, by the way. I'm very satisfied with that. The ability to hear somebody characterize a graph, and you can visualize what it looks like. That's a great skill set. So we know it's extremely relevant right now, and it's urgent, but it's been a problem that's been around for almost a lifetime. So it's a big thing. Here we go. A couple quick definitions just to get them out of the way and make sure that we have them formulated in our head and understand the relationship that these terms, where they interact. This is the most critical first definition. It's the sum of all conditions that support life. There are conditions on Jupiter. They're interesting to study, but they don't really matter. This is the only place in our solar system that has life, and that's the unique thing. That's what we want to study. Life is the key thing. So all of the conditions that support the existence of life on our planet, that's what the environment is. When you hear that word, that's what people are talking about. We're going to spend almost all of our year on this side of the which is at the pure sciences, biology, ecology, toxicology, chemistry. All of these things are environmental science. But the context that makes this important is everything that's on the blue side of the dial here. Economics, policy, ethics, mindsets, worldviews, all of those things. There's an interplay between everything in blue and everything in green. We're going to spend most of our time in green, but we're always going to look at it in context of what's in blue. So we have environmental studies as kind of the space where they interact. So we'll mingle in here, but we'll mostly be on the right side of the dial looking at the science of things, but always in context. So now, Planet Earth is excellent. I don't know if you guys watch Planet Earth, but another quick practice assessment sort of thing. If all of the conditions that support life is our definition for the environment, start making some observations and thinking about what do you see here that makes up the environments. And this is the trailer for Planet Earth, so they show you lots of different environments. There's tons of observations you can make. Then also list some adjectives that apply that help you describe the environment. 2-minute video. Here we go. All right, so number 1 is going to be all nouns, I think, right? So what did you see? It's a ton of different environments. What are the conditions of the environment that we saw? Give me some stuff. Trees. Excellent. These are all nouns, right? Trees. Yeah. What else? Grasslands. So this is a little bit larger, but it qualifies for sure. Oceans. What else?
Animals themselves.
Just animals, all types of animals. You see big mammals, we see lizards, all kinds of stuff. What else?
Human structures.
Human structures.
Or interaction.
Yep. What else? Clouds, fabulous. Keep going. Give me some more.
Presence of light.
Light, so sunlight, solar insolation, terrific. Wind, really good. What else? Maybe a couple more, 3 more.
The density of the animals, like how many there were.
Density of animals. Ice, so water in a different form than clouds. Yeah, what else? One more. Oh, there's one that's just super obvious. Air, that's the one that's really obvious. Give me one more really obvious one. What's everything on top of?
Oh,
Rocks and dirt and all of that, right? Fabulous. Now give me some adjectives for number 2. Diverse. What else?
I said some of it was kind of relentless and unforgiving.
Relentless, unforgiving. I like that. That's really rich, emotional. We're channeling our Rachel Carson a bit.
Connected.
Interconnected. Nothing that you see there exists in isolation.
Yeah.
Everything you see is connected to other things. What else?
Colorful.
Vast. Full of life. So these two things together, by the way, as terms of being a good scientist and sharpening your mind by identifying one thing and describing said thing, that's called a scientific observation. If you want to develop a competent scientist, that's the skill. So, when you look at things, get used to taking this practice of, I'm going to look at something and I'm going to describe said thing. That's a scientific observation. So what you guys have just described is the environment. That was outstanding. Look at this. Here's a couple terms that we can apply here to categorize all the number one, those nouns that you gave me. So we have abiotic. You probably recognize that prefix like asymmetric. It means the opposite of. Bio, that's the word for life. So we're talking about the things that are not life. Abiotic. These are the conditions in the environment that support life but are not life. Rock, air, water, temperature, nutrients, macronutrients, micronutrients available of molecules, all of those things. Those are the abiotic things. Then you have the biotic stuff. And it's, of course, interconnected. It's connected to the abiotic things, but biotic things are also connected to one another. They're very complex, and that interaction supports movement of matter and energy throughout the ecosystems, which you saw in the narrative in sentence number 3. So the abiotic and the biotic things. When we make observations, you can use these. These are the proper terms to refer to everything that you just talked about. Diversity. That was one of the key words that came out that you guys, almost everybody came up with that as a way to describe it. Diversity is key to sustained life. Our planet has been around for many billions of years. More diversity is better. So when we look at ecosystems and all of these levels of characterizing our environment, more diversity is almost always better. And so we have different levels. So when we look at diversity, and we can measure this as a scientific characteristics, and we'll do that actually as part of our class, we can actually understand and measure and look at differences and trends. But it's a key indicator to understand health, and more diversity is better. So in a macro level, you have ecosystems. This thumbnail, this whole picture is from the text in chapter 2. But the ecosystem diversity, you have marine ecosystem, beach, forest, mountain. Then you've got a shadow on this side. So we've got 5 ecosystems that can be seen. Those ecosystems. So an ecosystem is the largest level, and you have genetic or species diversity inside of that. So maybe 400 organisms. That is a diversity indicator that we can use as well. And that's the count and the evenness of all of the species inside of the ecosystem. And in the species ecosystem, when you look at a population, the chipmunks in this example, but the room is an example right in front of us. We're all part of the same species, but we have diversity inherent in our genetics. Look at the differences that abound. That's true. And an indicator that we can look at as well, and it's inside of each one of the different species. What's really amazing here is there's a lot that we don't know about this. So the species diversity globally is still a number we're trying to get our finger around, our thumb on. We've seen a lot of organisms, but there are many, many, many millions of organisms, especially small microorganisms that we don't even know, we've never discovered, we don't know what's out there. So this range, I think, is amazing. It's somewhere from about 5 million to maybe 100 million species, we think, of species across all of the 24 different ecosystem types. That's a huge number. A lot of species biodiversity is being lost every moment, and that's of huge concern. So the change of the earth. The first 3 sentences of the narrative, when we talk about earth as we expect it to exist, we'll talk a lot about the changes on the earth. The earth is a very dynamic place, and change happens due to movement of plate tectonics. It happens because of storms and changes in climate. It happens to volcanoes, all of these natural systems. And then we have a whole set of changes of the earth that happen because of humans. And there's a key term here that I need you to get right away. Anthropogenic. The first part of the root of that word, anthro, you're familiar with. Anthropology, that's the study of humans. Anthro, it means human. And then the genetic side means it's the genesis, it's the beginning. In other words, humans created it. Humans started this. So all of the changes, anthropogenic changes, are ones that we can link directly to humans. Here's an unbelievable statistic. There are twice as many people on the planet now as in 1960. There are 2/3 more people now than when I was born. The world is changing extremely fast. Each one of these people in their existence uses resources that our planet has. And so changes to our planet are happening very quickly because of people and what people demand in order to exist, and the number of total people on the planet. Really quick exercise. We're going to do this first one. It'll only take about 2 minutes to get through. Think about all the goods and services, ecosystem services, that you get from nature. And then you don't have to circle. If you're writing, you could circle or notate, or just kind of keep track of which are the ones that you can't do without. This is independent. Just go. Start making a list. We're going to do a little synthesis here. So take your list and make sure you kind of know which ones you think are important. And we're going to continue this formulation and go for a couple seconds. Here's our definition of ecosystem services in case you didn't get a chance to write it yesterday. And then a bunch of key examples there, right? That can help you complete your list a little bit. But now, in a group, and I don't care how big these groups are, but it makes sense to collaborate and synthesize some of this information together. So given what you reflected on from your life, think about how human development to provide these things have impacted the natural systems on our planet. And then to go along with that, how has this changed over the last 2 centuries? So what's true now hasn't always been true. Think about how it compares. As a point of reference, by the way, human existence in this species form is about 10,000 years old. So how has it looked? But together, talk it out. Go.
Okay. So some of the things I listed were clean air, water, economic this one I put was materials for innovation, which is kind of an odd one because the innovation is needed for the humans to survive and it exploits nature. Okay, yeah. Well, it's like my overused. I think that's the biggest idea. But we still have plenty of work. Yeah. Like we're air and stuff. Yeah. I think. Yeah. I think the important thing for the last 2 centuries is this demand for innovation. That finding new ways to do things is going to demand different materials.
For the last 2 centuries, like 500 plus years. process right now is it's a Swivl that legalize fossil fuels.
Yeah.
We need
All right, I hear a lot of really good things as I browse through the room here. I hear one of the big changes over the last 2 centuries is the amount of technology that's available, which impacts the amount of resources that can be used. Things like mining trucks is an easy example. I also heard a lot of people mentioning just the population, so this change in population, how much stuff people want. So there's been a lot of change in this space over time. Some of the biggest impacts have been to the land and the amount of total resources that have been used. Good job on that. We're agile as a 10-person group. You got through that really quickly. I want to talk a little bit about, in science, it's really key to measure things so that your characterizations have meaning and we can do comparisons and things like that. The way that we do this sort of science that we've been talking about right now, measuring impact, is this thing called the ecological footprint, which is a measurement, and it's always expressed in terms of land area. So we'll say how much land area is needed to support everything that's happening on the planet. So renewable resources are ones that can be replenished, and a lot of resources are generated by the earth year over year. Things like grass, timber. You can cut a tree down, but a new tree might grow, as an example, right? And so when we think about the land area, earth is constantly providing new resources in the terms of renewable resources. So we have that one major category. Then non-renewable, these I already, but I'm going to draw out here on non-renewable. That means that it's not going to be renewed in what makes sense in human generations. So fossil fuels is the big one. Fossil fuels is organic material from decaying ferns and trees and dead species and things like that. To be replenished for my grandkids, right? So non-renewable resources are ones that can't be renewed in the scope of human generations, right? And so when we think about the ecological footprint and land area, we're looking at how many resources does Earth provide versus how many are we using, and then measuring that across the Earth. So I want to look at this and think about the trends that you see here. So this is the ecological footprint, the total ecological footprint. There's a group of scientists that measure this, and they look and chart it out across societies. What trends do you see across this map here? Dark red, by the way, in terms of the scale, I know it's hard to read, is the most severe, and gray is the least severe. And when I took the picture, I was selected on Canada, so sorry it's grayed out there. Yeah.
So, like, the developed countries have the most impact.
So we have really high areas in the United States, developed areas, Europe, China, and India. So these areas aren't quite as developed, but why would they be so red? Dense population.
Yeah.
So with the development side, yeah, Fee?
Also areas with a lot of fewer environmental regulations, like so China and India.
Yes, places that have less environmental regulations, the impact can be slightly more severe. That's good. On that same front, I have another representation just in terms of forests, since we've been talking a lot about the Amazon rainforest here. This is the ecological deficit versus the reserve. And so if it's in a green shaded color, that means those ecosystems in those countries are producing more. And if it's in the red area, it means you're consuming more than the area is making. So what do you notice here?
We are not in the good spot.
Well, we're the worst. We're basically the worst. What about northern Africa, which on the previous slide was not very red? Why would this be red? It's desert. These aren't very productive ecosystems. They don't have very many resources to contribute. Right?
Why isn't
Go ahead.
Why isn't Russia more? It would seem like they have less natural resources to exploit.
The total land area is massive in Russia.
Okay.
Yeah.
Population density.
And population density, for sure. So this is really interesting, and I throw back to the Amazon rainforest as this case. In terms of ecological reserve is very high. they're exporting a lot of their resources that they have to other countries. So when we talked about the stakeholder groups, we are going from here to here. And places like the United States and in Europe, they're saying, I can't believe this is happening in the Amazon rainforest. They should stop this. And one of the prerogatives of the government, the stakeholder groups in that area is, who are you to tell how to manage our sovereignty? But we global ecosystem and ecological problems are global in nature. So this you can already respect, I think, that this is very complex, how all of this fits together and decisions are made. Yeah.
I was reading this article that was talking about was from a few people in, I think it was the Amazon rainforest thing, but also other environmental regulation questions of sort of more second world, I guess to use that for a better term, countries that are less developed.
Mm-hmm.
And they were kind of looking at countries like the United States and Europe and saying, well, you depleted all your natural resources, and now we're in this position, so that's so you could become developed.
Yes.
Why isn't it? It's not fair that we can't deplete our natural resources to become developed. Like,
This global worldview fairness, did everybody hear that? It is amazing. If you look out in Missouri, we have fields. We've already developed this area. You could have said the same thing 150 years ago about the state of Missouri. How dare you take the great oak forest down to plant soybeans and cotton fields? This is a very ecologically rich area. Well, we've already reconciled that we don't care about that, but for some reason we do care about the Amazon rainforest. This idea of global equity, fairness, and resource use is tricky. Yeah.
It's also a little hypocritical because we're telling them that
It's very hypocritical.
they need to stop destroying their rainforest, but at the same time we're demanding goods from them.
Yes.
Because we can't create a lot of them because of our environment and the fact that we already destroyed the majority of it.
In the radio clip, the gentleman, the scientist they're interviewing at the end as kind of a carpet sweep says you should really try to reduce the number of goods that you use, but people just don't know. And it's very hard even if you try to be educated and know where do your products come from. The global supply chain of resources is crazy. So there's a lot of ingredients in every good. You don't know where all those ingredients are sourced from. So it's a difficult thing to do. And the main message on that is we have to be sensitive because everything you've said is absolutely true. When we look at this, the supply and demand curve. So in 1960 is when we really started experiencing major growth in population. It's double now than what it was in the year 1960. This is what the resource use looks like. So everything in the red, we're using over the biotic potential. So that means, the biotic means how many resources can the earth contribute. There was a really good question in the group, why is going up? Well, that's because of agriculture, and some of human impact is actually increasing the amount of biotic potential on the planet, but you'll notice that's nowhere near the rate of productivity that we're demanding. In terms of land area, this is the ecological footprint. The biotic potential hovers somewhere around 10 billion hectares, and we're using almost 20 billion hectares. So another visualization of really the same data, but just to think about it, the total Earths. So we have the total land area of Earth being here. We're using about 1.5 times the biotic capacity of Earth right now, which is intense. There's this group of scientists that produce this thing called the overshoot, and if you want, you can go to this link later. It's really interesting where they're measuring at which point do we cross that threshold. This was the first year ever where that date happened in the month of June. So in the 6th month of the year, we had already used all of the resources, the renewable resources that the Earth could contribute. So guess what we're using now? The banked resources. So there's the depletion happening over time. Sustainable development is the main key definition here. It's the development that balances human well-being. So there's a social component of human health and the quality of life and the environmental impact, and then also developing and increasing quality of life over time. So these are the major component parts. We have urbanization happening. Of course, there's energy demand, and that's increasing. Of course, there's food demand, and that's increasing. All of those require resources. And then there's more people. Just as the earth is growing, we have 7.6 billion people now, and each one of those people requires things. So as we think in a sustainable way, we're going to definitely take the technology optimism approach in this class all year. But when we talk about sustainable development, that's what we're trying to achieve. High quality of human health, population, and society, but at the same time balancing the impact on the environment and then also increasing the economies and developing over time. I'm going to skip this because this was just an exercise. I think it's good, but we're going to advance on. And I wanted to show this. This week has been intense. I know you guys, you come back from summer break, and it's been a lot of me talking, and then it's been a lot of you in isolation on your computer looking at a lot of information. But mixed media literacy, it's just so key in the world that you guys are inheriting. And I put this on here as a look at how good you guys are. Look at the number of things we've accomplished in less than 3 hours of instructional time. You've looked at information and taken in information and processed information from all these different forms. It's been really impressive. I've been proud of this group so far. In terms of the summer assignment, if you didn't get it in yet, I'm by the end of the day today, so make sure you get those in to avoid any quick comment kind of penalty, whatever kind of thing. I can't remember who. I think I have most of them by now. But if you're that person, make sure you get it in. Otherwise, on Tuesday, for people who didn't get this message earlier, on Tuesday during our class in the long day, we're going to spend most of that time in the environment doing some characterizations on our campus. So don't come here. You'll have 5 extra minutes of passing period, but go down to the May Hill. The bridge is where we'll meet for class. And I'll see you there. All right? Have a great weekend, gang. Thank you for today. Take care of yourselves.
Thank you.